Today's warm-up is going to just be a review of the things we did over the last few days, starting with last Friday, the maximum number of roots, turning points, and end behavior. So in this polynomial, we have a degree of 3. So we're going to use that first term. Let's just circle that whole term. The first term to determine the roots, turning points, and end behavior. That's all you're going to need is the first term. And it's not the first term as written, it's the first term when the polynomial is in descending order. So that's highest to lowest power. To find the number of roots and turning points, you just need the degree of your polynomial, which is the highest power. So the degree, which is, we use n for degree, is going to tell us the number of roots. So the number of roots is equal to n. So roots, the maximum number of roots in this one is 3 because the degree is 3. And the number of turning points is just that n, the degree, minus 1. So turning points equals 2 because if n is 3, n minus 1 would be 2. And behavior, you have a chart in your notes from Friday. That would be the notes on graphing polynomials. If you look at the top in the header, it should say graphing polynomials. You will notice that you need to know whether it's odd power. So your power or your degree, n, would be either odd or even. And your lead coefficient, which we used a to represent, lead coefficient is a. The lead coefficient is a. That is going to either be a positive or negative. And this one is positive. So we have an odd positive function. And so our end behavior would be listed as x increases, y increases, as x decreases, y decreases. An odd positive. You'll need to have that chart to know those unless you memorized them. The other way you could do it is to put it in your calculator and just look at the ends of the function. So, okay, and the second question on here says to use synthetic substitution to evaluate for x equals negative 3. And these were the notes from, I believe, Tuesday of this week, or Wednesday of this week. Tuesday and Wednesday, but it was the last thing we did, synthetic substitution, in those notes. So when it says synthetic substitution, we're going to use synthetic division, but instead of putting the opposite of the number in the box, when it says a synthetic substitution, you're putting this exact number in. You're not changing it to the opposite. So negative 3 goes in the box. You still need your same coefficients, though. So 1, 3, negative 18, and negative 40. Okay, so now we're ready to substitute. Now once we did this, we substituted the negative 3 in. The number we get here, the remainder, is the answer. So bring down your 1, multiply around, add down, or whatever this first coefficient is you bring down, not just 1 if it's something else. Negative 18, and this is 54. If you put negative 18 times negative 3 in your calculator, you'll get 54. And so you get 14 for your answer. So this is the value of that polynomial if x is negative 3. Alright, so we're going to start with a review of simplifying radicals. If I tell you to, and you're going to need a blank piece of paper because this is not in the notes, so make sure you have one or two pieces of blank paper to take notes on. So we're going to put this in simplest radical form. And whenever I say simplest radical form, I do not want you to just put it in the calculator and give me the decimal version of this. I want you to simplify this down to the prime factors. So we're going to do 5 times 25. And 5 is a prime number, so I know that's going to be part of my answer. And then 25, I can multiply 5 times 5 to get 25. Now you're looking for pairs of values here. And I have a pair of 5s, and I have one leftover 5. Okay, so now under the radical, what I have is a 5 and a pair of 5s. This pair of 5s, if I take the square root of that pair, that equals 5. So in other words, what I have is the square root of 5 times the square root of 5 times 5. And that gives me square root of 5 times 5, because the square root of this is 5. This can't be simplified any further. So this is going to be 5 square root of 5. Number 2 is going to be the square root of 52. So you do 2 times 26, 2 times 13, and you have a pair of 2's. So now I have square root of 13 times 2 times 2. I can pull the 2 out front, and the square root of 13 stays under the radical. The third one, I'm going to change to the square root of 200. Square root of 200. Okay, the square root of 200, if I do, wait, I don't want 200 because that's coming up in a minute. 250. Sorry, square root of 250. So this is going to be 25 times 10. 25 is 5 times 5. But remember, 10 is 2 times 5. So don't make a mistake and multiply 5 times 5 to get 10. That would be adding. Okay, so now I have one pair of 5s, and I have a leftover 2 and a leftover 5. So under my radical, I have 2 times 5, and then that 5 times 5. So I pull out 1 5, and 2 times 5 stays under the radical, so you have 10 there. So I'm going to have you practice the first 2 here. So stop the video, practice the first 2, come back, and then we're going to do 3 and 4. So number 1 should be 2 root 10, if you do it correctly. And number 2 should be, let's see, that's 2 times 100, so it would be 10 square root of 2. Now, the second pair of problems we have here have a negative under the radical. So remember, if you have a negative under the radical, you have to use that little italicized I, which means is an imaginary number, and that equals the square root of negative 1. So whenever I have a square root of a negative, I can factor out the negative 1, take the square root of the other number, because I know this equals I. What's the square root of 16? Well, that equals 4. I don't even have to do my factor tree because it's a perfect square. So this is just going to be 4i. Square root of negative 80 is going to be square root of negative 1 times the square root of 80. So I have I, and then 80, I'm just going to do it to the side. 4 times 20, you could use 10 times 8, you'll still get the same answer. So I have 2 pairs of 2's and a 5. So 2 pairs of 2's, I'll have to do 2 times 2, which is 4, and square root of 5. So 80 is going to be 4 square root of 5. Now I have to multiply the I times the 4. I don't multiply the I times the square root of 5, because I is no longer under the radical, it's outside the radical. So it's 4i root 5. Okay, so I'm going to give you 4 examples I want you to try. So you'll have to stop the video, try these 4 examples, and then come back and I'll give you the answers. This is 5i, because 25 is a perfect square. 13 cannot be factored, so that stays under the radical, so that's I times the square root of 13. 20, we just, well, 20 is going to be 2 times the square root of 5, so this will be 2i square root of 5. And this one I'm going to break down because some of you may not have known what to do with this 8. So right now I have 8 times the square root of negative 1 times the square root of 18. Well, I know 8 and I know this is I, right? So square root of 18, this is 9 times 2, and 9 is 3 times 3, so I have a pair of 3's. So the square root of 18 is 3 times the square root of 2. So now I have 8 times I times 3 root 2. I have to multiply the 8 and 3, so that's 24. 24i square root of 2.